We're in homework number 7 now. So I skipped 1 through 4 because they're just review. So do you remember the rules of powers? Remember how that works? Again, your algebra days. Do you remember? What is 2 squared times... Let me do multiple choice. How about that? Here we go. A, 4 to the 5th. B, 4 to the 6th. C, 2 to the 5th. D, 2 to the 6th. E, none of the above. All right. Are we ready? We're going to vote as a class. You don't have to vote if you don't want to, but be interested in what you think. If you want to vote, and look at it for a second. Ready? How many say A? Nobody. B? Nobody. C? 5, 6, 7, 8 of you or so. D? Nobody. Maybe 1 or 2. E? No? I'm not sure. So the C was the most popular. Is it true? Yeah.
It's A.
It's A?
Yeah.
Some people say A. Some people say C. Anybody? How about this? Rather than, what's most important is the truth. Obviously that was a dumb statement, but I mean showing the truth is what I mean to say. Your ability to convince somebody else, because then you've really got it. So how about that? Can either camp convince the other camp? Can you give me a reason why it's one or the other? Yeah.
Well, it's going to be C because
Jesus,
10
yeah.
powers is 2 times 2, and then 2 to the 3rd power is 2 times 2 times 2. So you just add 3, the next one's the 2 and the 3.
I like the way you think, Jesus. Yeah. 2 squared, what does it mean? 2 2s. 2 cubed, what does it mean? 3 2s. What do you got? 5 2s. So what must be the rule? Yeah, the powers. Yeah. It's just what's true, isn't it? Math just follows the truth, like a hound dog following the scent. That's all they do. So the rule is you add them because that's what it is, huh? Good. Well said. Exactly. Excellent. So it's 2 to the 5th. It is 2 to the 5th. And so you don't actually multiply the 2's. Isn't that weird? You don't go 2 times, even though it's times, you don't actually go 2 times 2 and make it 4, do you? Why not? Because it's not true. I mean, in the end, that's always the final reason in math, because it's just not true. It doesn't mean 4 5s. It means 2 2s and 3 2s. It means 5 2s, not 5 4s, huh? So you just have to remember, when you're multiplying things with powers, you don't change the base at all. You only change the power, huh? Because that's what's true. All right, number 6. Explain how to use base 10 blocks to compute 3 times 50. All right, so they're just saying, would you know how to show kids that base 10 blocks is an excellent physical thing for kids to learn about carrying and borrowing and place value in the base 10 system. So how would you show them, up here if you can see it, it says 3 times, that dot is times, 3 times 52. It's not a decimal point, it's times there. How would you, with base 10 blocks, show the kids, because you can have them do it with symbols, right? Multiply this out, 3 times 2 is 6, 3 times 5 is 15, it's 156, But you really want those things to have meaning for them. Why is that really the right answer? Does this picture show it? Yeah, actually, this is this is an excellent picture. See what this is here? This is 50, because that's 5 things of 10 each. 52, this is a 52. This is another 52. This is another 52. So that's 3 52s, right? And it becomes, now what does it become? What's that big thing they got there? Well, let me show you what you would actually physically show kids. You've probably already got it, but let me just say it nonetheless. This is what they call a flat. It's all glued together. It's one big 10 by 10 100. This is 100. Remember our answer is 156. See it there? 5 of these, 6 of these, 1 of these. There's our answer. See, that flat is 10 by 10. How'd they get that flat? What'd they do? Yeah, they took these and together, right? That's 5 of them. That's 5 here and 5 here. And you put them all together. What would be called trade them in. You'd have a bag with everything there. And you would trade all those in for that one flat. So all of these become, it's like trading in 4 quarters for $1, or something, right? You're making change. So you're saying, look, these are 10, so let's just trade that in for a whole dollar, right? For a whole flat. And then what's left over? 50, and these guys, 6. See how that is? So that would help them to physically see that 52, 3 times is 156, isn't it? So it gives meaning to these numbers being in different place values. Your goal for the kids in the end is when they see that 1, they know it's 1 in the hundreds place. They're picturing a flat. So they're understanding it's got more value because of where it sits. And this is a physical way to get that value. All right. We have different ways. So let's talk about adding. So if I go 5 plus 2, you could model that on a number line. Yeah, we're here. Let's do 5 minus 2. 5 minus 2. If I show 5 things like this, and then I take 2 of them out, that's a model. I want to help you to understand the difference between a model and an algorithm. A model, because we have them both, and both have their place, and both are important. Model is not an efficient way to do a problem. It's a lousy way. You don't want to do a million problems drawing dots every time with arrows. It takes forever. It's not an efficient way to do a problem, but it's a way that conveys what's really happening, like the base 10 thing. So a model is a model shows the concept by pictures or physical manipulation. Physical manipulatives. Manipulatives. I can't talk and spell. All right, there we go. So that'd be like the base 10 blocks, that's a great way. That solidifies the concept. That helps the kids really think, hey, what am I doing when I'm moving those? Because the eventual goal, it's like there's three layers. I don't know if you've heard of these 3 layers before. People could probably make it more layers. But there's physical, manipulatives. I'm going to have to spell this word again. Physical manipulatives, layer 1. It's physical, it's concrete. Some people call it the concrete. It's like concrete is. It's hard. You can touch it and feel it. Layer 2 is pictures. Right? So that would be drawing the base 10 blocks like we just looked at. Or drawing this. This is a picture. So the first level could be actual beans in their hand. So you've got 5 beans, take out 2. That's called subtraction, So that's physical. Step 2 would be pictures like this one, or the picture of the base 10 blocks. And eventual goal, step 3, is symbolic. 5 minus 2 is 3. You want to get to the point to where that little symbol has meaning for them. That little dash in between the 5 and the 2, they feel it deep in their gut that that's taking something away. Right? That's the goal. So there's those 3 levels of thinking. Concrete, pictures, and then finally symbolic, to where they can actually, do, because you don't want to just start off with symbols right away and teach kids to move symbols around without any understanding at all. I see that a lot where I'm at in teaching college. I teach algebra, and I teach some lower stuff, some algebra, sometimes review from high school, and then I teach Calc 1, 2, and 3. And in all those levels, at different times, I'll see, really, a lot of people doing math by moving symbols around without really understanding what's going on. And then that just gets them in a world of trouble, and they mess up, and they don't know why they're messing up. I see it all the time. And so it says to me, they don't know what that symbol really is. It's just a symbol to them. I'm trying to think of an example. I see it all the time. I should have something off the top of my head. Something will come to me in a little bit. But anyway, so it's the difference between, when you get to the symbolic level, you want those to have meaning. Not just some, what's that? 2 bars here and the little dash there. That's takeaway. That's what's left over. That's going to come from concrete and pictures. It'll come from that whole thing. So that's what models do for us. Models give us physical manipulatives and pictures to make things sink deep. So when you get to the symbolic level, it has meaning for them. And it's not just moving symbols around. I can give you an example of multiplying. Yeah. Oh, you know what? Oh, yeah. Here's a good one. I was just doing this, I think, yesterday. I was doing a more advanced thing with some algebra students. And then we got to, it was pre-calc. That's right. It was my pre-calc students yesterday. And we weren't doing this, and that's not pre-calc. But I referred to it because they were confused when we were long dividing polynomials, something ugly. We had some functions. I won't bore you with too much pre-calculus, but we had some function that was doing something like this over 2x minus 3. And I was asking them about the oblique asymptote, which is a diagonal asymptote as that function goes to infinity. Whatever. I'm not going to bother you with it. But we had to long divide the polynomials to get it. And I was saying, okay, guys and gals, remember, if you want to divide this into this, it's like a big old fraction. That's what it is. And we had to long divide with polynomials. I don't know if you've ever done it. It's kind of awful. And we had to do that with x's and all this kind of stuff. But I noticed when we were cranking on down the line, and we got a final answer, we had something up here, whatever, blah, 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 and then we had a remainder down here. And I said to them, what do you do with the remainder when you're long dividing? They weren't sure what to do with it. And I said, okay, think back to when you were just a youngin' and you were doing something like 8 over 3. You had an improper fraction. I just suddenly broke away to just normal numbers. And I said, what did you do with 8 over 3 to change it into a mixed number? How do you change an improper fraction into a mixed number, like 5 2/3? How do you do that? You long divide. You go bottom into the top. You go 3 goes into 8. I'm going to get a little more room here. 3 goes into 8. And we'll do some of this in a couple weeks. We'll talk about fractions and decimals more. But real quick, I just want to show you an example. 3 goes into 8. How many times? 2 times. 6. Remainder 2. And then I said to them, what do you do with that remainder? What do you do with that remainder? Where's it go? Yeah, do you remember? It's this over that. Goes over the divisor. It's 2 2/3. So, and most people did. They're like, yeah, I remember that, 2 2/3. So I said to them, okay, so what we're saying is 8/3 is 2 2/3. But I said, but how do we say that with x's in some big old polynomial thing with x's? There's no such thing as mixed number polynomials, I said to them. That's sort of true. So what are we going to do? And it all came down to this issue. It all came down to, what does 2 2/3 really mean? And let me ask you the same question. Does it mean 2 plus 2/3? Or does it mean 2 times 2/3? Think for a second. What does this, because we needed to know that to do the pre-calculus. Because you had to know what to do with the x's, and it was one of those two. So I was saying to them, when you write 2 2/3, what does that really mean? Does that mean 2 plus 2/3? Or does that mean 2 times 2/3? What do you think? Is there any symbol in between? What have we learned when there's no symbol in between? Multiply? But that's totally wrong. Do you know it? And the best way to know it is to be real. And that is just it. I mean, I know that sounds funny, it's our last minute here, but let me say this. If somebody was to say to me, what does it take to do well in math? And I can give one sentence after 25 years of teaching a lot, over 10,000 students math, and my own 5 kids homeschooling and teaching them, and my wife knows that. I would say, be real with the math. So let me say to you here, be real. If I was to say, hey, I've got 2 2/3 pies in my cupboards at home. 2 2/3 pies. What does that mean? Does that mean I have 2/3 pies 2 times? Is that what I mean? No, nobody would think that. They know you've got 2 pies plus you've got 2/3 of another pie. It means plus. Well, why don't they put the symbol? Well, because it's some weird math thing. Whatever. Do you know, are you real with that when you write that symbol, do you know it really means plus? A lot of my pre-calc students didn't, and so we had to do that with the x's. But my point is, they've been writing these symbols for years, but it's just symbols to them. They weren't thinking, oh, that means 2 plus 2/3. They weren't thinking real, concrete enough with it. And so they stumbled all over the place when I was telling them what to do with the x's and the asymptote, more advanced thing. So that's what I'm talking about with models, concrete. All right, we are out of time.